Good morning, everyone. This is B. Ramarao from Government Polytechnic College, Station Ganpur. Today, we discuss about normality and relation between molarity and normality. Normality and relation between molarity and normality. This topic belongs to first year diploma student, first year, first semester, common syllabus in chemistry, subject code SC104. Topic: normality and relation between molarity and normality. What is normality? What is molarity? What is relation between molarity and normality? We discuss in this our topic: normality and relation between molarity and normality. Objectives. On the completion of this period, you would be able to know. On the completion of this period, you would be able to know. Calculate the weight of solute in a normal solution. Calculate the weight of solute in a normal solution. Calculate the weight of solute particles in normal solution. State dilution law. Understand the principle of neutralization. Understand the principle of neutralization. State the relation between molarity and normality. On the completion of this period, you would be able to know. Calculate the weight of solute in a normal solution. State dilution law. Understand the principle of neutralization. State the relation between molarity and normality. This topic discussed in this hour. Calculate the weight of solute in a normal solution. State dilution law. Understand the principle of neutralization. State the relation between molarity and normality. Define mole fraction. Calculate the mole fraction of solute and solvent. Define mole fraction. Calculate the mole fraction of solute and solvent solution. So, in this hour, we discuss calculate the weight of solute in a normal solution, state dilution law, understand the principle of neutralization, state the relation between molarity and normality, define mole fraction, calculate the mole fraction of solute and solvent solution. In the last period, we learned about normality. Can you recall definition of normality? Can you recall the Definition of normality. It is defined as the number of gram equivalents of solute present in 1 liter of solution. It is defined as the number of gram equivalents of a solute present in 1 liter of solution is called normality. Normality, it is defined as the number of gram equivalents of a solute present in 1 liter of solution. What is equivalence? The weight of the substance. The weight of the substance that react with 1 gram of hydrogen or 8 grams of oxygen. Weight is called equivalent weight of the substance. How many number of equivalents present in 1 liter of solution is called normality. So, we calculate the normality of solute particle by the equivalent weight of particles. So, in this hour, we discuss, can you give equation for normality? Normality n is equal W by GEW into 1000 by V in milliliters. V in milliliters. So, what is normality? The number of gram equivalents of solute. The number of gram equivalents of solute present in 1 liter of solution is called normality. This normality is denoted by capital N. Therefore, normality N is equal number of gram equivalent of solute by volume of solution. Normality N is equal number of gram equivalents of solute by volume of solution. That is equal small n by V. Small n by V. So, normality N is equal number of gram equivalents into 1000 by Vm. This number of gram equivalents is equal weight of the solute by gram equivalent weight of solute. That is W by GEW. Weight of solute by gram equivalent weight of solute into 1 by V in liters. In case given solution volume in milliliters, therefore normality N is equal weight by gram equivalent weight into 1000 by V ml. Units of normality is equal gram equivalents per liter. Normality decreases with increasing temperature due to increasing in value. So, where W is equal weight of solute in solution, weight of solute in solution, gram equivalent weight is equal gram equivalent weight is equal GEW, means gram equivalent weight of solute. V is equal volume of solution in milliliters. Volume of solution in milliliters. So N is equal W by GEW into 1000 by V in milliliters. Therefore, normality N. Calculation of weight of solute. Calculation of weight of solute. The weight of a substance present in a given solution is given by the weight of a substance present in a given solution is given by W is equal normality into gram equivalent weight into volume in liters. Volume in liters. The weight of the substance present in given solution is given by formula W is equal normality of solution into gram equivalent weight of solute into volume of solution in liters. In case volume of solution in milliliters, therefore W is equal normality into gram equivalent weight into volume in milliliter by 1000. So N is equal to normality, N is equal to normality, GEW, gram equivalent weight, GEW means gram equivalent weight, V is equal to volume of solution in liters. Calculation of weight of solute. Calculation of weight of solute. See here problem. How much of sodium carbonate is required to prepare 500 ml of 0.02 N solution given gram molecular weight of sodium carbonate is 106. How much of sodium carbonate is required to prepare 500 ml of 0.02 N solution? Given solution normality 0.02 N, volume of solution in milliliter 500 ml, gram molecular weight of sodium carbonate 106. We calculate the gram equivalent weight of sodium carbonate. Then weight of the substance W is equal normality into gram equivalent weight into VML by 1000. So the weight of the substance calculated by using formula in milliliters, N into GEW into VML by 1000. So given data, normality N is equal 0.02 N GEW, gram equivalent weight is equal gram molecular weight by gram molecular weight by 2, that is equal 106 by 2, that is equal 53. 53 gram equivalent weight of sodium carbonate. Gram molecular weight of sodium carbonate 106. Sodium carbonate charge is equal to, therefore salt component gram equivalent weight is equal to the ratio between gram molecular weight and its charge. So gram equivalent weight of sodium carbonate is equal to gram molecular weight by charge. Gram molecular weight of sodium carbonate 106, charge is equal to, that is equal to 106 by 2, so 53. How much of sodium carbonate is required to prepare 500 ml of 0.02 N solution given gram molecular weight of sodium carbonate is 106. Volume of solution milliliters, 500 milliliters, Therefore, volume of solution in liters 500 by 1000, that is equal 0.5 liters. 0.5 liters. Therefore, 0.5 liters. Normality n is equal 0.02 n. Gram equivalent weight 53. Volume of solution in liter 0.5 liters. Therefore, formula weight of the substance W is equal normality into gram equivalent weight into V in liters. Therefore, W is equal N into GEW into V in liters. Hence, N value 0.02 into 53 into 0.5 liters. That is equal 0.53 grams. Formula weight of the substance W is equal normality into gram equivalent weight into volume of solution in liters. N is equal 0.02, gram equivalent weight 53, volume of solution in liter 0.5 liters. Therefore, W is equal 0.02 into 53 into 0.5, that is equal 0.53 grams. Now, neutralization reaction. Neutralization reaction. Principle. In neutralization reaction, one N acid is completely neutralized by one N base irrespective of their acidities or basicities. In neutralization reaction, one N acid is completely neutralized by one N base irrespective of their acidities or basicities. If a solution of normality N and volume V1 is neutralized by another of normality N2 and volume V2, then they are related by the equation N1 V1 is equal N2 V2. If a solution of normality N1 and volume V1 is neutralized by another solution of normality Nu2 and volume V2, then they are related by the equation N1 V1 is equal N2 V2. N1 normality of given first solution, V1 is equal volume of solution first solution. N2 normality of second solution, V2 volume of second solution. Then both are neutralized together, then equation N1 V1 is equal N2 V2. N1 V1 is equal N2 V2. One can calculate either volume or normality of solution. One of the solution knowing the corresponding values of the other from the above equation. Problem: 50 ml of 0.2 H2SO4 solution 50 ml of 0.2 H2SO4 solution is neutralized by 75 ml of NaOH solution. What is the normality of NaOH? What is the normality of NaOH? 50 ml of 0.2 H2SO4 solution. First solution H2SO4 solution and another solution NaOH solution. What is the normality of NaOH? 50 ml of 0.2 H2SO4 solution is neutralized by 75 ml of NaOH solution. What is the normality of NaOH? Given data, here given two solution, one H2SO4 solution and another one NaOH solution. Given data, volume of H2SO4 solution V1 is equal to 50 ml, volume of NaOH solution V2 is equal to 75 ml, volume of NaOH is equal to V2, that is 75 ml. Normality of H2SO4 solution N1 is equal to 0.2 N. Then calculate the normality of NaOH N2 is equal to how much? Here two different solution, one H2SO4 and another one is NaOH. These two solutions neutralized between together 50 ml of 0.2 N is neutralized by 75 ml of NaOH solution. Then calculate the normality of NaOH solution. Volume of H2SO4 V1 is equal to 50 ml, volume of NaOH V2 is equal to 75 ml, normality of H2SO4 N1 is equal to 0.2 N. Then calculate the normality of N2. Here two different solutions, one H2SO4 V1 is equal to 50 ml and N1 is equal to 0.2 N. NaOH V2 is equal to 75 ml. Then calculate the N2 of NaOH solution. Formula N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. For this equation, therefore, N2 is equal to N1 V1 by V2, 50 into 0.2 by 75, that is equal to 0.133 normality. 0.2 N 50 ml of H2SO4 is neutralized with 75 ml of 0.133 N NaOH solution. Hence, normality of NaOH solution is 0.133 N. Now, dilution law. Dilute solutions are prepared by adding water to concentrated solution. Diluted solutions are prepared by adding water to concentrated solution. Addition of water in concentrated solution then form dilute solution. In this dilute solution law, if a solution of normality N1 and volume V1 is diluted to a normality N2 and volume V2, then the following equation holds good. N1 V1 is equal N2 V2. If a solution normality N1 and volume V1 is diluted to a normality N2 and volume V2, then the following equation is N1 V1 is equal N2 V2. The amount of water added is given by V2 minus V1. The amount of water added is given by V2 minus V1. What is the volume of water to be added to 500 ml 1 in sodium carbonate solution? 2 has to make it has 0.1 n. 1 n 500 ml of solution, it turns to 0.1 n. How much amount of water to be added given 500 ml of 1 n sodium carbonate solution? What is the volume of water? What is the volume of water to be added to 500 ml 1 in sodium carbonate solution so as to make it 0.1 in solution? 0.1 in solution. Given data, volume of solution V1 is equal to 500 ml. Normality of given solution of sodium carbonate N1 is equal to 1 n. Then normality of dilute solution N2 is equal to 0.1 n. Volume of dilute solution V2 is equal to how much? Once again, see here, what is the volume of water to be added to 500 ml 1 in sodium carbonate solution so as to make it has 0.1 in solution? Volume of concentrated solution 500 ml. Normality of concentrated solution N1 is equal to 1 n. Normality of dilute solution 0.1 n. Volume of dilute solution V2 is equal how much? Formula N1 V1 is equal N2 V2. N1 V1 is equal N2 V2. For this, V2 is equal N1 V1 by N2. Dilution law of normal solution N1 V1 is equal N2 V2. Therefore, volume of solution for dilution V2 is equal N1 V1 by N2. N1 V1 by N2. N1 V1 is equal N2 V2. Therefore, V2 is equal N1 V1 by N2. Therefore, V2 is equal V1 500 ml into normality of solution 1 by 0.1. 500 into 1 by 0.1. That is equal 5000 ml is final value. 5000 ml final value. V1 is equal 500 ml. V2 is equal 5000 ml. The amount of water to be added given concentrated solution, that is equal to volume of water V is equal V2 minus V1, that is equal 5000 minus 500, that is equal 4500 ml of water added to given solution, then it is turns to 0.1 in solution. 0.1 in solution. Volume of water to be added V is equal V2 minus V1, that is equal 5000 minus 500, that is equal 4500 ml of water. According to dilution law, N1 V1 is equal to N2 V2. Therefore, V2 is equal to N1 V1 by N2. N1 1, V1 500 by 0.1, that is equal to 5000 ml. V1 500 ml, V2 5000 ml. Volume of water to be added to solution. B is equal to V2 minus V1, that is equal to 5000 minus 500, 4500 ml of water added to given solution. Now, relation between molarity and normality. Molarity and normality. Molarity and normality are related as molarity into gram molecular weight is equal normality into gram equivalent weight. Therefore, molarity into gram molecular weight is equal to normality into gram equivalent weight, where GMW gram molecular weight, GEW gram equivalent weight, gram equivalent weight. Knowing any three values, the fourth value can be calculated from the above equation. Molarity into gram molecular weight is equal to normality into gram equivalent weight. For acidic solution, molarity normality is equal to molarity into basicity of acid. Normality is equal to molarity into basicity of acid. For base solution, normality is equal to molarity into acidity of base solution. For redox reactions, normality is equal to molarity into change in oxidation state. Change in oxidation state. Problem. Molarity of H2SO4 is 2. What is its normal? Molarity of H2SO4 is equal to 2. Therefore, what is normal? Here, relation normality is equal to molarity into basicity of acid. For base solution, normality is equal to molarity into acidity of base solution. So, problem, molarity of H2SO4 is 2m. What is its normality? Data, gram molecular weight of H2SO4 is equal to 98. Gram molecular weight of H2SO4 is 98. Gram equivalent weight of H2SO4 98 by 2, that is equal to 49. Molarity of H2SO4 2m. Then calculate the normality of given solution. Therefore, molarity and normality relation, molarity into gram molecular weight is equal to normality into gram equivalent weight. Therefore, normality of H2SO4 is equal to molarity into gram molecular weight by gram equivalent weight. So, normality is equal to molarity into gram molecular weight by gram equivalent weight. Molarity 2 into 98 by 49, that is equal 4m. 4m. Molarity and normality relation. Molarity into gram molecular weight is equal to normality into gram equivalent weight. Therefore, normality of solution is equal molarity into gram molecular weight by gram equivalent weight. Molarity to gram molecular weight of H2SO4 98, gram equivalent weight of H2SO4 49, 2 into 98 by 49, that is equal to 4m. Therefore, molarity, number of moles of solute present in 1 liter of solution. Number of moles of solute present in 1 liter of solution is called molarity. Molarity M is equal moles of solute by volume of solution in liters. Therefore, M is equal moles of solute into 1000 by molecular mass into volume of solution in milliliters. Therefore, moles is equal molarity into volume of solution in liters. Millimoles is equal molarity into volume of solution in milliliters. The number of moles of solute present in 1 liter of solution is called molarity. Therefore, molarity M is equal number of moles of solute by volume of solution in liters. Therefore, M is equal number of moles of solute into 1000 by gram molecular weight of solute, that means molecular mass into volume of solution in milliliters. Therefore, number of moles is equal molarity into volume of solution in liters. Millimoles is equal molarity into volume of solution in milliliters. Concentration of solution, normality, number of gram equivalent of solute present in 1 liter of solution. Therefore, N is equal number of gram equivalent of solute by volume of solution in liters. Therefore, N is equal mass of solute into 1000 by equivalent mass of solute into volume of solution in milliliters. Also, N is equal equivalence for volume of solution in liters. Therefore, equivalence is equal N into V in liters. Milli equivalence is equal N into V in milliliters. Therefore, number of gram equivalents of solute present in 1 liter of solution is called normality. Therefore, normality N is equal equivalence of solute by volume of solution in liters. Therefore, N is equal mass of solute into 1000 by equivalent mass of solute into volume of solution in milliliters. Therefore, N is equal equivalence per V in liters. Equivalence is equal N into V in liters. Milli equivalence is equal N into V in milliliters. V in milliliters. Equivalent mass of acid. Equivalent mass of acid. Equivalent mass of acid is equal molecular mass of acid by number of H plus ions replaced by acid. Equivalent mass of acid. Equivalent mass of acid is equal molecular mass of acid by number of replaceable H plus ions, that is basicity. Therefore, equivalent mass of acid is equal gram molecular weight by basicity. Equivalent mass of HCl and H2SO4. HCl replaces only one H plus ion, so its basicity is equal to 1. H2SO4 replaces 2 H plus ions, its basicity is equal to 2. HCl and H2SO4 equivalent weight of acids is equal, therefore equivalent mass of HCl is equal one hydrogen and one chlorine present in HCl, hydrogen atomic weight 1, chlorine atomic weight 35.5, that is equal 36.5. Gram molecular weight of HCl is equal 36.5 by basicity of HCl is equal to 1, 36.5 by 1, that is equal to 36.5. So HCl gram molecular weight is equal to gram equivalent weight. Here second acid H2SO4. This H2SO4, it is ionization of H2SO4 to H plus SO4 minus 2. So here number of H plus ions replaced from H2SO4 is equal to its basicity is equal to 2. Equivalent weight of H2SO4 is equal to H plus S 4 oxygens, 2 hydrogen atomic weight 1, 2 into 1, sulfur atomic weight 32, oxygen atomic weight 16, that is 4 into 16, 2 into 1 plus 32 plus 4 into 16, that is 98 gram molecular weight. Its basicity is equal to 98 by 2, that is equal 49. 49. So here acid equivalent weight calculated by using gram molecular weight by basicity. Equivalent mass of base is equal gram molecular weight by acidity. What is acidity? The number of OH minus ions replaced from base is called basicity. Acidity. Equivalent mass of NaOH and calcium hydroxide. NaOH, it produces only one OH minus ions. Its acidity is equal to 1. NaOH, Na plus OH minus ions. It replaces only one OH. Its acidity is equal to 1. Therefore, equivalent mass of NaOH is equal 1 sodium, 1 oxygen, 1 hydrogen. 23 plus 16 plus 1, that is equal to 40. Gram molecular weight of NaOH is equal to 40. Its acidity is equal to 1. Therefore, equivalent mass of NaOH is equal to gram molecular weight by acidity 40 by 1, that is equal to 40. Second one, calcium hydroxide. Calcium hydroxide, it ionization Ca plus 2OH minus. So here acidity of calcium hydroxide is equal to 2. Calcium hydroxide gram molecular weight on calcium, 2 oxygens, 2 hydrogens. Calcium atomic weight 40 plus 2 into 16 32 plus 2 into 1 2. 32 plus 2 34 plus 40, total 74. So gram molecular weight of calcium hydroxide 74. Equivalent weight of calcium hydroxide gram molecular weight by acidity 74 by 2, that is equal 37. Equivalent mass of salt is equal gram molecular weight by charge on cation or anion. So gram molecular weight by charge. Equivalent mass of NaCl and magnesium chloride, sodium chloride, Na plus Cl minus ions, its charge is equal to 1. So equivalent weight of NaCl is equal 1 sodium and 1 chlorine, 23 plus 35.5, that is equal to 58.5. So gram molecular weight of sodium chloride 35.5, 58.5 by 1, that is equal to 58.5. magnesium chloride Mg plus 2 plus 2Cl minus. Charge is equal to, here magnesium atomic weight 24 plus 2 into 35.5, that is equal 95. 95 by 2, that is equal 47.5. Relation between normality and molarity. Therefore, normality is equal mass absolute into 1000 by molecular mass by n factor into volume of solution in milliliter. Therefore, normality is equal molarity into n factor. If HCl n is equal to 1, H2SO4 n is equal to H3PO4 is equal to 3, NaOH 1, calcium hydroxide 2. For monovalent compound n is equal to 1, normality and molarity is same. Calculate the molarity of 0.6N AlCl3. Its charge is equal to 3. So AlCl3 gives Al plus 3 plus 3Cl minus N is equal to 3. Therefore molarity M is equal normality by 3, 0.2 M. Thank you once again. On this completion of this period, you would be read about what is normality, what is molarity, what is relation between molarity and normality, what is normality solution, what is dilute solution, what is relation between molarity and normality. So thank you once again. Thank you.